So, hello. Thank you all so much for joining us today. We're really thrilled to see so many attendees. Welcome to the first Getting the Best Out of Coax with our friends from Amphenol Broadband Solutions. For 76 years, the SCTE has been a champion of knowledge, dissemination and education. We have a lifetime of standards, training, experience at our fingertips. And thanks to our broad membership, relationships with the best in the business. As an agnostic learned society, we feel perfectly positioned to offer a series of carefully curated webinars for the broadband sector. Given the extenuating circumstances, it also seemed entirely in keeping to harness the technology we've got and supply the broadband to bring that knowledge to you at the kitchen table or wherever you may be sitting right now. I'm delighted to welcome Amphenol Broadband Solutions as the first lucky subjects, or victims, depending on how they see it right now, of the SCTE's webinar series. With offices in 40 territories and a track record that spans nearly 90 years, Amphenol Broadband Solutions are global leaders in electronic and fiber connectors and cable and the whole thing. They're going to come more into the whole lot of this. Our session, entitled Getting the Best Out of Coax, will, I have no doubt, entertain and educate in equal measures, hopefully. It's easy to overlook the coax network, as there's so much ongoing noise about fiber, full fiber rollout, broadband, taking it up, moving up, speeds. We all recognize coax still has a role to play. I'm confident by the end of this session, you will all come away with a bit better informed about the capabilities of this technology and how to continue to utilize coax. I'd like to welcome Tim Cook, Director of Product Management at Amphenol Broadband Solutions, and Nick Padfield, Technical Product Manager at Amphenol Broadband Solutions, to our first webinar. Ably moderated or kept in check, as it usually goes when we're engineers, by the SCTE's James Harwood. James, as many of you will be aware, is Learning Experience Manager, L&D at Virgin Media. He has first-hand experience of Amphenol's product line. Reem Barn and myself will be putting some of your questions and our own to Tim and Nick. James, the floor is yours.
Thanks, Tony. So before we get stuck into the webinar and getting the best out of coax, I just wanted to share with you a kind of brief agenda for the day. So shortly I'll be handing over to Tim and Nick, and I'll be delivering a short presentation on getting the best out of coax. We'll then be following this up with that Q&A kind of panel session. At that point, I'll kind of fully introduce the experts who will be answering all of your questions. So we've already had some great questions submitted kind of ahead of the webinar. Some of you have been submitting by email and such. And I've been pulling those together into a bit of a flow to get us started when the session begins. But I also wanted to take a moment to kind of let you know and remind you to ask your questions as we're going through. So when the presentation starts shortly, any questions that pop up, we want you to ask. My job as moderator is to pick up as many of these up as possible and fire them at the panel on your behalf. So ask away. So the way we're going to do that is via the chat function within Zoom. If you can't see it on your screen currently, just have a little look around. Normally at the bottom, you'll see a little button called chat. If you type whatever question you've got in there, and just direct it towards as an option for panelists, that will make sure it comes through to me. And while we're going ahead with both the presentation and the questions, I'll be diving into the chat, grabbing some of your questions and flipping them straight away into our panel of experts. So when you are submitting your questions, remember to keep them sensible and on topic. I'm not sure how many of you will be interested in knowing what Tony's favourite colour is. Maybe his favourite colour of coax. Actually, I might write one down. We might come back to that one. So yeah, keep them relevant, keep them on topic. Obviously, the title is around getting the best out of coax. already interested to see some of the questions are mentioning fiber quite a lot, so by all means ask away and I'll chuck them in front of the panel for you. The webinar has been recorded and the chat function, so once again just keep them clean, and obviously that's for any of those that aren't able to attend, or any of you that want to look back on any questions and answers. That go ahead. So enough for me at this point. I think my real work starts just after the presentations. I'm going to hand shortly into Tim and Nick, but just before I do, I just wanted to do a quick introduction for both. So first up, you'll be hearing from Tim Cook. As Tony mentioned, he's the Director for Product Management for Amphenol Broadband Solutions. In this role, he supports all facets of engineering and product development through collaborative work with customers as well as industry standard organizations. Drawing on his deep experience in product design and engineering, Tim leads the strategy and development of current and next generation solutions for the broadband industry. His associations include the SCTE, the National Fire Protection Association, and the National Electrical Safety Council. I'm also going to introduce Nick at this point so I don't disrupt the flow in the middle of the presentation, but Tim will be handing in to Nick. So Nick Padfield. So Nick is Technical Product Manager for Amphenol Broadband Solutions as well. His role is primarily supporting customers to uncover and understand their needs and translate these into requirements, and work closely with product development teams to provide a solution. Nick has gained a broad range of RF engineering experience since graduating from the University of Birmingham. That's my town. And draws on his knowledge to work closely with Amphenol's engineering teams around the world. Nick is also a member of the SCTE. So Tim, Nick, over to you.
Thanks, James. It's a privilege to be with you guys this afternoon to discuss coax and how we can get the best out of coax. My part of the presentation and the agenda is to discuss the coax history, the basics of coax, and then the standards and specifications associated with coax. Coaxial theory dates back to Maxwell in the 19th century. The earliest telephone and telegraph cables that spanned the Atlantic consisted of a mere central conductor with a latex insulator. And surprisingly, seawater was used as the outer conductor of the first coax. Not a mechanical insulator, but a fluid outer conductor. The concept of coaxial cables was first patented in Great Britain by Oliver Heaviside, a British mathematician and engineer. The first British patent was number 1407 and was granted on April 6th of 1880. 4 years later, in 1884, Siemens and House would obtain a similar patent. The first patent in the U.S. for coax is 1835031, and this was assigned to American Telephone and Telegraph, or AT&T. In this patent, coaxial cables are illustrated as a transmission line for telegraph, and get this, with a bandwidth of 1 to 1.5 hertz. Also mentioned was telephone and TV applications, albeit the primary purpose was for transmitting television signals. And in 1937, the initial trials were conducted utilizing coax for transmission of television signals. This was from New York to Philadelphia, and it happened to be the Republican National Convention. During periods of war, coaxial cables, their role was expanded for military applications, particularly that being of radar. Radar arrays were installed along all throughout Great Britain in the area for detecting incoming enemy planes. And that's where it really gained its first real world application. After World War II, the focus reverted back to its original purpose and design, that being telecommunications. As the applications and technology expanded, so did the use of coax. The manufacturing processes and materials used as the components of coaxial cables evolved to meet the new challenges and are still very much relevant in this connected world we live. Moving on to the Cable 101 portion, there are three main components that make up a coax: the interconductor, the dielectric, and the outer conductor. The interconductor can consist of copper, copper-clad aluminum, copper-clad steel, plated copper conductors such as with silver, and they can either be solid or tube types. Dielectrics from the early latex or rubber type insulation or dielectric have evolved to the more sophisticated gas injected foamed polyethylene dielectric. That's what's most common today for your general purpose coaxial cables. Outer conductors consist of solid aluminum tubes, braided outer conductors such as copper, tin copper, or aluminum. And with these braided outer conductors, they can be with or without laminated shielding tapes in multiple layers. Also, a type of outer conductor can be copper. It can be a corrugated copper as well. All these depend upon the application and the shielding requirements for the coax. When an engineer sits down to design a coax, there's many variables or parameters that they need to be aware of and take into consideration. These are just a few of the parameters and the formulas that are used in designing a coax. It's a more complex task than one might realize. As far as standards and specifications, there are multiple standards organizations that are relevant to the coaxial cable industry. Some of the primary ones are depicted here on the screen, being the IEC, SINELEC, SCTE, ISBE, MIL standards, and others. And they have, in my opinion, they are the primary reason that coax has enjoyed the longevity and the usefulness it now shares today in the broadband network because of these organizations. The IAC Domains section of standards and specifications that apply to the CATV or broadband industry are the 61196 group of documents, -5 being for the trunk and distribution cables, and -6 for the drop cables. Within the SCTE ISBE organization, the ANSI SCTE 15 is the one for trunk and feeder distribution coax, and SCTE 74 is for the braided 75 ohm flexible RF coax drop cables. With each of these specifications and standards, there's a myriad of test procedures that these organizations develop and publish to support these standards for the extended RF bandwidth of greater than 1 gigahertz. As mentioned earlier, this interoperability that these standards offer to both customers and manufacturers, allowing products to be used across vendor platforms to ensure performance, greatly has attributed to the longevity of the product. These organizations recognize the need to identify performance of coax cables to extended frequencies of 3 gigahertz and beyond, and it is a top priority. Cable Labs, MSOs, and the SCTE have formed a consortium and collaborate to issue the new DOCSIS 4.0 standard. In this standard, it leverages the existing HFC network and currently is extending the frequency band to 1.794 gigahertz with provisioning for performance to 3 gigahertz. All of these operators realize that coaxial cables perform at these higher frequencies without the need to rebuild to a fiber to the prem network. Ability to meet the customer's ever increasing need for bandwidth, network speed, and quality of service with a minimal capital investment. You know, we're here today to talk about getting the best out of coax and the future of coax. MSOs such as Liberty or Virgin Media, Charter, Shaw, Comcast, Cox, and Comcast all recognize that coax will be a vital part of the broadband network for decades to come. I can, 30 some years ago when I entered the industry, I can remember told that, fiber is going to replace coax. And, I've heard it all throughout my career in this industry, and it's still a vital part of the network, and it still has a longevity and usefulness in years to come. This was validated, the usefulness of the coax in this network was validated last year and continues through the COVID-19 pandemic. The current HFC network has exceeded expectations, allowing millions to work from home and students to learn remotely, and even in telemedicine to be accelerated into use. Even as fiber does push deeper towards the premise, engineers are seeking ways to repurpose coaxial cables to power the network. And with that, I will now turn it over to my colleague, Nick Padfield.
Great, thank you very much, Tim. I'll just grab the screen and I'll continue. So I'll just get you to stop sharing, Tim, and I'll grab control.
Gotcha. There you go.
Thank you. Hi, I'm Nick Padfield, and I'll talk about where coaxial cable is used in the network and the expected migration from coaxial to fiber cables. So there doesn't seem to be an absolute model for transitioning from a coaxial cable to a fiber to the premise or fiber to the home. And throughout the cable TV industry, we're seeing many different approaches being explored. So I'll be discussing some simplified architectures and how coax cable is evolving to fit in with the transition to fiber, and also considerations past the electrical specifications of the cable to the material requirements to meet building code regulations. There's an ongoing trend to fiber deeper and bringing the fiber closer to the premise. And eventually, for maximum bandwidth, the goal is for fiber into the premise or the home. So it may be surprising to some that fiber to the home shouldn't be the only focus for fast broadband. So cable TV network operators can use their existing coax networks with head-end and distribution equipment that supports the next generation standards to supply 1 gigabit service to their customers and beyond. So fiber to the home is still far from the norm for a majority of subscribers in the UK or mainland Europe. And with current trends, the choice for the majority of consumers is not likely to overtake traditional copper or coaxial for several years to come. The UK government has a gigabit broadband availability goal of 70% by 2025. And I think there's similar goals within the EU. So going back to coax and existing coax networks, the coaxial cable networks are a valuable asset, and they will already support the next generation DOCSIS standards. So the next step is to 1.2 gigahertz operation for DOCSIS 3.1 and the potential in the standard to use frequencies, as Tim said, up to 1.8 gigahertz and provisions for 3 gigahertz as well. So the humble coax will operate up to these frequencies with linear roll-off in performance. So there are modems available today that will support 2.5 gigabits downstream on a coax network. And the 3.1 specification for DOCSIS defines a maximum achievable speed of 10 gigabits per second downstream. So next generation duplex DOCSIS, which is now part of the DOCSIS 4 specs, the upstream can flow up to 6 gigabits, along with the downstream of 10, and this is all happening concurrently. So it feels like cable TV and the broadband landscapes at a tipping point. Over the next few years, there'll be a large mix of architectures and available services. So up to a point, the way TV and broadband is delivered will be determined by the end consumer and their requirements. So I've got a couple of slides on maybe the evolution of the network as seen from a quite high level, but it just shows where coax is evolving to where we are today. So here there's a legacy tree and branch network with coaxial trunk cables and cascades of amplifiers. So it's not unusual to have node plus 10 amplifiers between the premise and the node. It seems like there's been an operator-wide push to reduce the number of amplifiers down to n plus 3 to ease that transition to fiber deep and node plus 0 amplifier architectures. So here we have the signal from the trunk network feeding taps to distribute signals to the home. But there's also been an evolution in the requirement of the cables to increase the shielding level to a higher class and meet the A++ standard for both the in-home and the drop cables. So the main driver for the increased shielding requirements is the coexistence with mobile phone networks and the higher powers of signals that are being transmitted. So the diagram represents probably the goal for the current generation of coaxial networks, to have a fiber deep architecture with legacy nodes supporting 2,500 homes, with each child node supporting maybe 50 to 128 homes. So this is node plus 0 without any amplifiers in the network between the node and the premise. There's also further evolutions with DAA, distributed access architecture. So this is take remote PHY and remote MAC-PHY. So this is where functionality in the head end is being moved closer to the end user. So by having the equipment that performs these functions closer to the premise, it enables higher performance and higher bandwidth. So the traditional last mile from the street level distribution cabinets to the premise is mostly unchanged, still using the existing coaxial drop cable and used with RF-based CPE, customer premise equipment, so the modem and the set-top box. This style of architecture also leads itself to RFOG, which is RF over glass. So coaxial drop cable being replaced with a fiber connection to a mini node to convert the fiber signal to an RF signal, again, to support that RF-based CPE. So from reading around the industry, it seems the aspiration is to eventually migrate to a network which is full fiber passive optical network. So here's a simplified diagram of PON network, which will allow services to be supplied to many homes over a single fiber. So the fiber is brought into the neighbourhood with passive splits, the signals fed to homes, where there will, instead of being an RF transmission, there'll be an optical network terminal in order to deliver IP-based services, such as voice over IP for telephony, internet services, as well as IP-based TV. So the home set-top box is probably likely to be replaced with maybe an app in the TV or a small Wi-Fi dongle. So the only coax in the home at some point in the future is possibly only going to be the aerial for broadcast services. So we're already in that transition period from coax to fiber. There's still a few stages to go and a lot of homes to upgrade before we get to full fiber. So the current generation of CPE being used is RF based. So the set-top box and the broadband modem, these require the coaxial input. So this is the case if the premise is connected to a coaxial drop, or if it's fiber to the home, there'll be an RFOG node to turn that fiber signal into the RF for the customer equipment. So the transition to fiber is most likely going to be influenced a lot by the end user and the services they require. So there's reports of lots of consumer trends of things like cord cutting. So where the end user no longer requires the broadcast linear TV and consumes their video through IP-based streaming services. So further reports discuss the possibility that operators will eventually move away from the set-top box and video be offered through an app. So again, this mix of customer requirements with and without broadcast TV could dictate the final drop to the home and whether it should be coax or fiber. So Tim mentioned a Siamese cable with coax plus microduct. The microduct is tubed to allow fiber to be routed to the home, or in some cases, the fiber could be pre-installed into the microduct depending on requirements. So there's a good case for a hybrid cable so that low data users and slow adopters of upgraded CPE can sit on the legacy coaxial network where high data users and new IP-based CPU users are moved to the pure fiber network, or a mix of both. So this mix of architectures mean that distribution points in the outside plant cabinets could be a mix of coaxial distribution and fiber distribution. So this would mean the customer drop would need to support both RF on the coaxial cable and the provision to install fiber. And also the same for the cabling in the home. So the case to use the hybrid cable is that today one cable is laid to the home and in and around the home. And this can support linear TV across the coax for an RF-based system. And then there's provision there to introduce fiber, either to the modem or in conjunction with the RF linear TV or without. So effectively future-proofing the home to support a mix of services for years to come. So with these new solutions aimed at in-home and new build, the developments there are more considerations than the electrical performance of the cables. So since 2017, there's been a requirement for classifying cables to CE European standards for reaction to fire. So I'm going to very briefly talk about outlines of the specs and what we're seeing is being required. So the purposes of the specs were to quantify some of the labels used in terms of low smoke, zero halogen, indoor, outdoor. The new regulations were more to focus on the end product rather than just the jacket material. So previously a jacket compound was chosen, and this was then put on the cable and a label based on the performance of that jacket material. So the EN 50575, which is the name of the spec, the European spec, details the level of performance for the end product and outlines requirements to meet a certain Euroclass level between A and F. So the picture here is of some Amphenol cable being testified in a third-party notified body lab. And here's just a very sort of brief outline of what all the different classifications of the cables mean. So class A is a non-combustible and the most fire-resistant category. So it's specialist material, specialist testing procedures, and it's only sort of used for cables that must continue to function in the event of a fire. So B to D require the format of testing shown in the photo. So this is 3-meter strands of cable attached to a metal frame or a ladder and a burner applied at the bottom. And the test system measures things like heat output, smoke production, along with other details. But the results of the test define the overall classification levels for the cable from B1 to D. So B1 and B2, minimal flame spread and heat production, and C is still very small, where D has very similar characteristics to wood as defined in the limits, but without a flame spread limit. So the cable can burn the full 3 meters in the test. So class E is a simpler test that just looks at a single strand of cable, and class F is essentially a catch-all for cables that don't meet class E. So this is my last slide, and just a bit of an outline of what all this means in terms of costs for cabling and where it all goes. So with the additional testing, there's a cost associated with this, as well as the materials. So this slide at the bottom shows a little bit more detail of the test chamber and a ladder filled up with cables ready to go in the test. So at the lower end of the cost model is sort of the Euroclass E and F, which are this sort of simple one-off test requirements with standard jacket materials. And then you start to jump to the more expensive testing with DCA and more interesting jacket materials, because you have that more involved costs with the testing. And then from C and above, on a recurring annual basis, you have to keep repeating this test and requalifying every year and having those certificates available. So in the bottom right-hand corner, this is kind of a typical higher class indoor cable, showing that it meets the CCA requirement for heat release and flame spread, and the best possible specification for smoke density, and also D0, indicating no flame droplets, along with the best category for acidity. So these are likely sort of terms that you're going to see quite a bit. So that's a whistle-stop tour of cable in the network, where evolutions can be made in the short term to accommodate the trend to fibre deeper, and how coax can sit with it in the network for several more years to come. And also just a small hint about what other design considerations there are for this new build environment. And I believe that's probably our time, and I'll hand back to our moderator, James. So thank you very much.
Thank you, Nick, and thank you, Tim, before that. So you thought that was the hard part, delivering that presentation. Unfortunately, I'd now like to welcome you both to take your virtual seats up on the panel. I'm just going to do a couple more quick introductions before we get into the panel. Apologies for the background noise. So first I wanted to introduce Rian Barn, who is the Vice President of the SCTE. Just a quick introduction from Rian. So Rian started back in the early 70s in the Cat-V business with Oak Holland and in the set-top converter business. And after 5 years, moved into the Cat-V network construction and installation with Delta Cable in the Netherlands. He then started his own company, Proditel, setting up a distribution network in Europe and selling Cat-V components required to build cable TV networks. And then again with Delta Cable, he was involved in the first European introduction of cable modems. And the final panel member, aside from Tim, Nick and Rian, is Tony, who you met at the very start. Brief introduction from you. I'll get you to say this one.
Thanks very much, mate. Yep, President for the SCTE and Regional Sales Director for Technetics. Been in cable for 28 years now, so it's getting a little bit of a long time. And I can hear what Tim was saying about being told at the start, coax cable's dead, why are you going into this business? It's kept me here for 28 years. And I still don't know when it's going to stop. So back to you, James.
Awesome. Cheers, Tony. So before I start firing questions out, there's quite a few coming through. I didn't realise that Zoom's also got the Q&A function, which I think a few of you have found. So two options, obviously, stick it in the chat and direct it to the panelists, or stick it in the Q&A function. I can mark it off as answered and stuff now. So the fun now begins for me because I get to fire all these questions at our panel on your behalf. So, let me just double check. Anything else? No, I think we're ready. So panel, are you ready?
Yep. Yes, sir.
Yep.
Awesome. First question, straight to you, Tony. What's your favorite color of coax?
Oh, that's a difficult one. It's got to be the rainbow flavored in multiple colors, multiple flavors, and also with a banana peel on it to make it a little bit more attractive to opening. Come on.
I've never seen that one. No, we'll get on to the serious questions now. So like I said, we've had some great questions already submitted, and I've seen some really interesting ones. And actually, thank you for all. You've also been nominating who you'd like to answer, which means I don't have to be the bad cop in this scenario and give them questions I don't want to ask. But by all means, ask away and I'll ask the panel. If you do have someone in mind that you would like to answer, just drop it in the question and I'll make sure it's directed towards. So first question up, and Tim, you've got the pleasure. So it seems some of the coax going into the ground, or some of the coax in the ground, has been there for quite a while. Is there a specific lifetime of the various cables?
Well, that's a question I've been asked quite often over the decades, I would say, and there's no canned answer for the life of the coax. It primarily depends upon where it's installed, the latitude, the craftsmanship involved in the installation, and how it's abused, with the climate or mechanical abuse such as wind and trees or brushes and the like. All these play a role in the longevity and the lifespan of a coax. I have witnessed hardline cables that were installed prior to me even coming into the industry, and were still being used by the MSO with 30, 35 years plus of life. And they were still performing well beyond their original specs and expected life. The underground and the hardline cables tend to last longer than the aerial drop cables, but there's no real canned answer on the number of years or how long a cable will last. It's a quite a number of variables that come into play in that.
Awesome. And staying on the kind of theme of legacy cables, is there a theoretical limit to, you know, the types of frequencies that they can handle? Are we going to see that with some of the legacy cables? I'm actually going to direct this one to you, Rian, first of all, and then come back to you, Tim, as well. So it's a bit of a twofold, but Rian, interested in your input first of all. So in terms of legacy cables, do they have any problems above certain frequencies? Is there a theoretical limit?
I think, again, this depends on the type of cable. I think the focus is now on the limit on the drop cables, because most of the other signals are being fed via fiber, and only the last part of the network, there you need the frequency space. But in the Netherlands, it has always been up to 1 gigahertz from the start. So the cables were specified as such. And yes, they tried it up to 1.8 gigahertz, but it's not so much the cable which is limiting the frequency range. It's more the connectors and the passives, because in general, the higher the frequency, the more sensitive these components get.
Cheers, Rian. Tim, anything you want to add on that, on the limitations or challenges around frequencies and legacy cables?
Sure. The types of manufacturing processes that go into the coax, that can have a bearing on the operation of a coax and the frequencies that it will support. Some of the legacy fused disc type cables had mold spikes that had a severe suck out at a 1.1 gigahertz frequency. Other coaxes with the foam polyethylene dielectrics, although they were spec to 1 gig, we're finding that they perform adequately up to 1.8 and beyond, even to 3 gigahertz. I agree with Rian that the interconnect or the interface there is more so the limiting factor, and even we have recognized that early on, and actually have a new interface that we're developing that will extend the frequency of the interface to 18 gigahertz. So the life of the coax can be extended through the interconnect and the MSO and vendor community working together to implement these changes.
Awesome. Thank you, Tim. Once again, there's a bit of a theme kind of going on here, so we're going to stay on the future use, and this one's coming towards you, Nick, this time. And this one's actually from the Q&A. So Nick, how confident are you that older kind of 30-year-old trunk coax and hardline connectors will be able to handle the higher frequencies specified in extended spectrum DOCSIS?
So probably on that extended sort of spectrum for the hardline and that, I don't know how important those aspects will be in terms of for DOCSIS 3.1 up to those 3 gigahertz frequencies. As Rian and Tim said, the most likely place that they'll see any sort of issues with frequency range is more that drop cable and those interconnects. You know, as the cable gets a lot smaller, it's probably going to be those fine issues in between the cable and the connectors that's going to be the issue. You know, if these trunk cables, you know, if we're talking about hardline, 1/2 inch to 1 inch cables that are out there, these are probably more likely going to be the ones that are going to be overbuilt with fiber deep. So we'll probably see those sorts of cables not being used as much, and everything will go a bit fiber deeper. And then it'll all be the critical elements will be that final drop section where the cables become a lot smaller. And again, it comes down to that relationship between the connectors and the cable interface.
So,
one of the things you're going to have to look into this is more when you look at how the connectors are built. So how they're going to continue through. Are they still linear all the way through? Experience of my own says they're not linear as you start going up in the frequency. So they are built to stop at 1 gig, 1.2, 1.3. As they start going up, you're starting to get more non-linear functions coming in. And it will have some influence on these frequencies. Of course, the higher you go up, the more fun you're going to have with these unlinear functions coming into it. So that's where I think the biggest problem will come from, the connectors. But again, connector manufacturers have been tuning these connectors for the last 10 years, knowing that frequency needs to go up. And looking at it, hardline connectors, will these be overbuilt? Most probably. So
yeah, and just adding to that, I think, you know, the higher data rates, the signals are getting more complex. So they're the bits that become more susceptible to the noise and distortion. And, you know, which is the reasons for removing amplifiers from the RF chain and in that kind of legacy sort of trunk network. So this, you know, there's been a lot. There's been getting cables to be class A++ to get, you know, that shielding improved, and then there's on top of that, there's extending the frequency range, but also extending it in a linear fashion as well. So, like you said, I think it all goes back to the cable connector interface along with the passives up to the CPE. So able to use that extended frequency range, it all has to kind of fit one after the other and make sure we sit, you know, in the dynamic range that's required for those signals in order to be decoded and turned into sensible signals by the time they get to the home.
Awesome. Yeah. Oh, there goes my phone. Let's get rid of that.
Apologize.
Yeah, thanks for that. Just put me off. Actually, Nick, you've part answered the next question, so I'm probably just going to invite the wider panel just if there's anything else you want to add. So the next question that was kind of lined up was, are there any other considerations outside of kind of the coax itself in order to support stuff like DOCSIS 3.1 and any future specifications? You've touched on a few there, Nick. So just to the rest of the panel, anything else you'd like to kind of add from that, aside from the coax, any other considerations for the future?
Well, I think one of the big things we're going to be looking at is actually the coax cable itself with the attenuation that comes through the coax cable.
Exactly.
The coax cable, the more attenuation, the less signal you're going to get at the end of it. If we keep going up in frequency, you're going to have to start finding ways of boosting the signal, changing the signal, reinvigorating this signal as you go down the line. You can't just keep going further and further, higher in frequency. It will cost somewhere. And this is one of the sort of the considerations with coax. The further you go down that 300, 400, 500 meters, 300 yards, 700, 900 yards, you're getting into the area where all of a sudden there's not a lot left. So if you look at a piece of coax as a water hose, by the end of those 1 kilometer, there's not a lot of water coming out unless you've got enough pressure behind it. So for me, that is one of the considerations. And all of these networks have been built 450, 600, 800, 1 gig max. No one started thinking about what do we do at 1.8. So there's still some rebuilds that are going to go in. When you start thinking about rebuilds, what do? Do you add an amplifier? Do you rebuild with fiber over it? So these considerations will come in. So we need to find ways of, if we're going to keep the coax, boosting the signal, making sure that signal gets to the end of it.
Maybe what I can add to that, Tony, is, well, from, again, not all over Europe, but in the Netherlands, we have already, from the beginning, star-shaped networks. like a telephony network with fiber length up to you suitable for UHF frequencies. But what we found is I'm connected, for instance, to a network already with 1 gigabit speed available on an HFC network. But I know that the coaxial part of the network has been very thoughtfully upgraded and secured and improved to even make that possible. Because the higher data speeds, it was mentioned before, if you go to higher data speeds in quad modulation and high speed IP traffic, every little suck out, which was not a problem before, becomes now a problem and gives you a bit error rate. And that was in the beginning of in the days of standard distribution, even analog, there was no problem at all. But with data transmission, and these networks will, if they are not yet, they will be fully used for data transmissions only, coaxial networks, I mean, that becomes a very sensitive factor. So it's not only the cable, but all the components will be, will be very important to upgrade it.
Cool. I've got one more question kind of on coax itself, and then I'm spotting quite a few future technology and fiber and 5G type questions coming through. So I'm going to have one final one, which has come from the chat. And actually, Tim, this one's coming your way. So about the history of coax, was it the coax guys or the connector guys who settled on 75 ohm impedance, and why wasn't it 25, 50 or 120 ohms?
Good question. The reason that was because there was a balance between the power that was needed to be transmitted through the coax versus the RF aspect. 50 ohm was chosen for the cellular wireless market because of the power needed in these antennas and the transmission. 75 ohm really, that impedance matched the center-fed dipole antenna back in the day, and in a free space. And so that's why 75 ohms was selected for the broadband industry, the cable television industry. They have lower RF power levels and didn't need the heavy metal content on the interconductor that the 50 ohm and the wireless guys needed.
Awesome. Hopefully that answered whoever asked that one. Cool. So going to move it kind of forwards a little bit now, and the next kind of couple of questions are a little bit more around the kind of the interworking and the future in a fiber world and stuff like that. So first one I'm going to throw your way, Nick. Hearing and reading loads around the benefits of fiber over cable. What's your opinion on that?
I think the big one is what Tony touched on. Basically, it's that attenuation factor. You know, as you go up in frequency and we're trying to get higher bandwidth and more signal down, you know, nobody said it yet, but you know, the fat pipe that we hear about, that's just, you know, basically just pumping in internet into people's homes and everything hanging off the end of it. So in terms of a pure pipe into people's homes for internet services, then absolutely fiber's there. But you know, a lot of the reason that we're looking at these next generation coax standards is because actually, you know, the coaxial cable still has a lot of life in it. You know, as Tim said, it was originally put in the ground to support, you know, 400, 500 meg systems, and they work well up to 1 gigahertz. And now we're looking at it, and actually, you know, these humble bits of coax that are still out there and passing millions of homes. You know, even here in the UK, it's millions of homes that are being passed, and it'll support easily 3 gigahertz. You know, as long as we're mindful of interconnects, then this network can still be used, and it's going to take a lot of time to get fiber everywhere. So if we can upgrade elements of the network to take fiber deeper to then overcome some of these attenuation factors on the coax side.
Oh, have we lost Nick?
But if you're taking the fibre deeper and then you're going to use it in the last kilometre, then there's still enough, you know, attenuation up to maybe that 3 gigahertz level that using these next generation DOCSIS standards, you know, that's the whole point. It's you know, internet protocol over cable. It's there to use that bandwidth that's usable, and where you start it off is the important part. So, you know, in an ideal world, yeah, probably you'd go back and but the operators already have this great resource that's there, that's usable, that will work. So it makes sense to evolve the equipment behind the coax network to use it for longer. You know, and we always hear about, you know, do we all really need a gigabits per second download speed? You know, telephony uses hundreds of kilohertz or hundreds of kilobytes, and you're streaming video, you know, your HD. So suddenly this need for a gigabit, is it really there? And if you can take the existing coax network up to a gigabit and further, then maybe it's there to be utilized for more than a couple of years. Maybe it's there, as Tim said, you know, it could be there and working for another 10, 20 years maybe, and still be a useful resource for you know, the country basically, and people to use.
Awesome. Tony, I know you touched on this before. Did you want to add anything else to that?
Well, I was actually thinking about why they're still developing sort of DOCSIS, why DOCSIS is still being pushed forward. We're looking at DOCSIS 4, DOCSIS 5. I think one of the big factors is when that stops. If someone says, you know what, enough DOCSIS, we're going to stop all of this, we're going to go away from fibre over coax. As soon as that comes, that will be sort of the first sign that, yeah, coax is hitting the problems. But I still, looking at it now, coax is still here, getting up to 30 odd years, it's still there and will still be used. So it is, if people are still developing something to put through it, it will still carry on. One of the things about speed is if it's there, people are going to use it. I mean, one of the pressure tests has been Corona, COVID-19. It's been a pressure test for the whole network where everybody, theoretically, it should have all collapsed. It's still working. It's still going on. I know there's been a lot behind the scenes to change things around, move some things, make sure that bandwidth is there. But it's just shown the network is more resilient than we thought it was.
Awesome. So question now coming your way, Rian. Can coaxial co-live with fibre to the home or fibre to the premise type topologies or architectures?
Yeah, I think I have seen examples of this. Really, that, you know, there are operators in the Netherlands who decided to put a fiber network 100% in parallel to the existing coaxial network. So in the end, when that was done, they could offer their services both on coax and on fiber, up to the customer to decide. And the idea behind that was to do, in the end, all the high-speed services, like high-speed internet access and two-way services on fiber, and use the coaxial network as it was used before, just as a distribution network. That is simpler in maintenance, and you have two options. You can have two groups of, or different groups of customers satisfied. And in the end, you still can offer FM radio, which is now disappearing off the coaxial cable because of DOCSIS 4.0. So there are some profits to gain about having a coaxial network in parallel to a fiber network. And in the end, the coaxial network is still being used. That counts for the Netherlands. You are maybe not forced to take the coaxial network out. You're still using it. So yeah, there are, I see a good existence for both networks together.
Cool. I'd also put your name against this one, Nick, just conscious that you did drop out for a second there, so I will just ask it again. So for you, how can coaxial co-live with fibre to the home or fibre to the premise?
I think I touched on it in my presentation, basically, that while there's still that adoption happening and the need for different levels of service for customers, that perhaps, you know, these hybrid style of cables, you know, Siamese cables aren't new. They've been around 20, 30 years, but before they'd have had twisted pairs and coax, you know, basically on a Siamese basis, so you can run telephony and RF. So why not evolve that to have coaxial cable with a microduct or with fiber, or even, you know, with a Cat6 cable, to give that basically option between both. So with the drop cable being replaced by a hybrid style of cable with an RF coax and a microduct, then if the fiber deep isn't there today, but it's going to be at the cabinet at some point in the future, if that new drop cable is put in to support both the RF coax and a microduct to blow a fiber, then you can today put a customer on with legacy RF customer premise equipment with broadband modem and a set-top box. And as fiber gets into the area, you know, and the customer says, hey, I want faster broadband, I'd quite like to go past the limits of what I can get through the RF. And I would like fiber, but, you know, you still have the option then of then running fiber to a fiber input modem to maybe give more than 1 gig, and then either have it in conjunction with or without the RF for a set-top box, if that's still what customer requirements are. You know, I get to start thinking about parents and older generation who've had the move from, you know, traditional aerial to Sky and satellite TV and to coaxial TV broadband from cable TV providers, you know, still using, you know, telephony and broadcast TV, not wanting to move to Netflix or Amazon Prime or Disney Plus or any of these services. So yeah, there's going to be a period where both are needed. So the coexistence, why not have the option there? If you're going to run a cable, as long as the duct space is there, if you're taking out a traditional Siamese cable with telephony and coax, and you're no longer going to be using the telephony because you've moved for a voice over IP, plugging a phone into a modem, that modem either being, you know, supplied by coax and RF or fiber, if the duct space is there, then why not put the microduct next to the coax and run it to the home, and equally in and around the home. So yeah, it's thinking of making it accessible, whatever the customer requirements are, you know, without having to go back and overbuild. If it's there, and an install tech can blow fiber back or just connect as required. So yeah, bit of a long-winded answer, but why not have both?
Cool. Going to take us in a slightly different direction now. A topic that's kind of really interesting from my point. So, Tony, I'm going to chuck this one your way. Is there a call for any kind of coax cable network training? Are you noticing any trends in any topics in particular, or any reasons that are driving this kind of training need?
To be honest, yeah, there is still the need. Looking around, some of us are getting grayer. We're the ones that have been there to start some of this coax up. We're actually teaching others now how to use that coax and how to understand it. I'm looking at some people that are saying, what do we do with coax? Do we just get rid of it? No, doesn't make sense. Yeah, but what do we use it for? When you start telling them what they can use it for, they're sort of, really? You can, on this? Yes, this works on that. So coax is still going to be there. If you look at some of the foundations of the coax, it's basically just a pipe that's sending signals. All of these signals doesn't really make any difference. If you go into a higher form of modulation, It's still using some of the basics. So all of the basics still apply. That's why if you look at SCTE training, we've still got a whole training compendium. At the moment, we're trying to put even more courses onto it. DOCSIS 3.1. When the new standard comes out, will it be DOCSIS 4, DOCSIS 5, DOCSIS 8, DOCSIS 12? Hopefully. We're also looking towards the fiber side of it, because fiber is coming in. If you just look sort of where the SCT is based in the UK, there is some government restrictions, if you can wait on how the network can be built. So there's also that need for that training. How to climb up a telegraph pole, connect something up. You can't just do that. You've got to be certified to be able to go up that pole to start with. So training in itself, the theory is still there. All of the theory still applies. All of these things that stop us putting 5 gig of data, 5 gig, pushing it as far as we can, millions of megahertz pushing down there. There is the theoretical side of this, which we're still keeping people alive with, still keeping things running. So the theory side of it is very much there, and why there's still people needing to put a CPE into a house, why the coax is still there. This training is still there. A lot of the training that has been given out is by someone sitting next to you. Bob taught me how to do this, and this is how I've done it. Might not be the right way, but it works. One of the places I'm looking at the moment is India. India have gone mad and said, we want every single village to have a fiber connection and speeds in excess of what we're looking at in Europe. How are they going to do this? Well, one of the things they've found out, training, we need training. Look at the UK. The broadband needs to be higher. We need to get more to more people, fiber everywhere. Where are the hands, the feet, the heads to do this? So training is still a very big part of all of this. And training to do it properly once it is still there. It's the most important thing you can do.
Cool. So I'm going to come to each of you now for a quick top tip. We know one of the biggest challenges with cable networks is loose connectors. So one for each. I'm just going to come around the table, but if you can give us a top tip. So for someone joining the industry new or quite kind of early on that might not have that level of understanding why tight connectors are so important, what would that be? So Tim, I'll come to you first.
Get yourself a good torque wrench and do not exceed the torque of the manufacturer, because you can do just as much damage over torquing a connector as you can having a loose connector. With the newer continuous ground type connections, they do a lot to mitigate ingress and egress, but again, follow the manufacturer's recommendations as far as torque.
Awesome. Cheers, Tim. Rian, into you. What's your top tip for tight connectors?
Whatever you use, make sure the interconnection between the cable and the connector remains, in all cases, 75 ohms. So you don't have a suck out or whatever. That is, so maintain the impedance of the cable. And the second one is shielding, because that becomes more and more important. We are using frequencies for our data transmission on the coaxial network, and ingress and egress, that counts for the cable as type of cables as well, of course, but also for the connection. So those are my 2 points of major interest.
Cool. Nick, for you, obviously your top tip, but if you could summarize why for a new starter or someone that doesn't quite have the fundamentals for cable, why is it that tightening connectors is so important in the plainest English you can do?
It's like a leaky tap, basically. As we've said, ingress and egress, these more complex signals need to have no noise around them in order to work properly. And, with the LTE networks and 4G, those signals coming in can disrupt everything. So you want a nice ground, a nice tight connector, and make sure everything stays out. And again, as Reen said, that cable connector interface. So you want to make that cable connector interface be 75 ohms and high shielding to meet that class A++ and stay there. And maybe slightly controversially, hey, don't use a threaded connector. Why not use a push-on connector? You push it on and it's on. In conjunction with a decent shielding at the back, then you've got everything you need, you know? So yeah, there's the case to move to push fit. And I know that that makes it easier for the end user as well. So yeah.
Cool. And Mr. Basham, anything?
Yeah, follow up on all of these. Finger tight is not enough. Too tight is too much. Just tight is perfect. But if you're talking about in the network, with the leaky tap analogy, you can't see it's leaking.
No.
And that's where it becomes the difficulty in all of this. So making sure it's tight in the network is so important. Making sure it's tight in the customer premises is just as important, because all of that signal goes backwards. So all of a sudden you're taking down the whole network because you've got a bad connector. So again, push fit, can totally agree with it. Just make sure that when you're doing the push fit, the grounding's there and not the center conductor. Because if the center conductor's there and there's no ground, you're just setting yourself up for a nightmare with a great big aerial on it. It's perfect.
Yeah.
Is that making sure the connection is there?
I think, Tony, you know, this is a very important issue, because I've seen networks who wanted to use high-speed data traffic, and the first thing, well, it wouldn't work, and the only thing they could do is reinstall all connectors in the network, and that solved 90% of the problems.
Yeah, I've been there, I've done it, I've seen it. I've put enough connectors on now to also know the first ones I did probably weren't that good. They were on connectors. And not knowing how much grounding you really needed and making sure it was perfect. Because I learned from Bob. Bob told me, just put it on, it'll be okay. This is where that knowledge that this is the most important connection you've got. Without it, there's no signal going down it.
Yeah. Cool. I've had a question come in on the chat, and it leads in quite nicely to the kind of final couple of questions. Nick, you mentioned something about screening, so I'm not going to come back to you for this question necessarily, but I'm going to fire this one at Tim. Why is it important to have a good screening rating with the likes of, you know, LTE interference?
Well, you think about the amount of noise that's in the home, or you know, near a cellular tower, or just in our world today. We're bombarded by RF noise, and that can ingress into the network. It can interfere with the transmission of the signals. Shielding is, you know, one of the more important parameters that engineers address today when designing new coax or designing connectors, the interface, making sure the integrity of the shielding is there to meet this need. You know, like Nick mentioned with LTE and the 4G cellular networks, that was a huge problem when it first rolled out with the broadband network. And, you know, we as manufacturers had to step up and make sure and develop new cables that improve shielding performance and make sure that that carried through with the connections. The Internet of Things, you know, and that RF noise that's in the home, you know, with appliances and HVAC systems and the like. There's just so much noise out there that can bring down the network or slow the network down.
Cool. So now onto the topic a little bit around that kind of fixed mobile convergence piece, or coming from that fixed line into more mobile technologies. So just an open one to the panel. I'll let one of you jump in. But how do you look upon the competition between cable and wireless technologies such as 5G in terms of stuff like capability, capacity, and actually probably more importantly in some circumstances security? Anyone want to have a go at that one?
Well,
don't make me pick.
Yeah. In general, James, you still need a network to transport the 5G signals to a central point. So it's maybe a plus-plus combination.
I would agree on the cellular backhaul system for the 5G networks. That's in the U.S. That's being a primary repurpose of the coax is for the backhaul aspect of the network. So they have to coexist together.
Yeah, just to continue on from that, it's just out there in the industry, we're seeing the links between, the likes of Virgin Media and O2. So there's obviously the synergies are there between the traditional coaxial networks and fiber networks with the cellular networks. They all use that same backhaul, and at the end of the day, it'll all just be IP traffic. There's a few specifics around the 5G transmission. Maybe the current, things like latency might not be important to everybody, but if you've got a hardcore gamer, they don't want any latency at all in their internet service. So with a fixed network connection, then maybe their latency is down in that 10 to 20 milliseconds range, where 5G or 4G at the moment, I think it's up nearer 50 milliseconds. 5G networks currently, I think they're sitting between that 30 and 50 mark. I think theoretically the 5G networks can get down to 1 milliseconds, but again, it's that evolution over time and what's important for certain people. So again, there's going to be that choice, the pipe into the home, whether it's wireless or wired, is going to depend on what the customer use is and what the cost is. So, we have that link between the coax for maybe slower data users, fiber for faster data users, and maybe 5G and fiber are complementary. And it's going to evolve over time. So yeah, it's one of those, I think they can all live together depending on what the requirements are.
No, I totally agree with that one, because with the cell sites getting smaller and smaller, you still have some fixed connection to them. Doesn't matter what you do, the fixed connection needs to be there. So with these cell sites getting smaller and smaller, are you going to put a new piece of cable in to make it work? Not really. You're going to try and find ways of making it work. So that's why I see the coexistence of this. And to be honest, there's enough bandwidth in a coax cable to also do it. So.
Oh, and a bit of a future state question that follows nicely on from that one. And once again, open question to the panel. So can any of you see a future 10 years or more where all TVs or in-home devices are connected to, for instance, 5G, and that cable and fiber take that step back slightly and become the connection for all of those transmitters? Can any of you see that future? Or if not, how would you see the next 10 years or so?
I mean, let's be honest, getting that signal in there has become more and more important. Everybody is using whatever function to get there. And these are not going to stop. I mean, if you want to see, if everybody in the house wants to see something different on 4 different apps, whatever they are, you're talking about some bandwidth going through it. If this is all going to go through one transmitter, why we've still got some legacy equipment around. This is going to be a way in. It's going to be like a stepping stone. I don't think you're going to fiber a whole house up. I don't see it happening. So you're going to still need to have some wireless connection somewhere. So I think eventually, yes. Will it be 5G? Will it be microwave technology? Will it be whatever? It's going to get there. But I don't think we're looking at sort of the next decade. There's enough going on at the moment just to make sure the speeds are there. Once we've got everybody up to that speed, maybe. But while we're still talking about this isolated areas that don't have even that capability yet, I think we've got a long way to go.
Yeah, and just to echo what Tony said, I think the focus isn't on that headline speed at the minute. It's trying to get a usable speed for more people, you know, which is why there's these more rural initiatives, you know, government-led, trying to get, you know, fibre deep is probably going to be the way to do it, to support, you know, fibre homes, because you're not going to be able to get those links, wireless links, out that far. So yeah, it's more about bringing everybody up to a base level than maybe the absolute speed. But there's always going to be those special needs for having a certain speed for certain applications. So I think, yeah, the proliferation of all of them is going to be around for 10 years. I mean, you know, when you look at things like how long it's taken to switch off analog TV signals and move from 2G to 4G and 3G in between, you know, all of these signals can coexist. There's nothing to say you have to switch one off to have another. So why impose a limit of how long you can use any of these technologies? So yeah, I think a bit of everything for many years to come.
And you know, I was thinking about that, even as fiber pushes deeper into the network, and if the fiber is even, you know, feeding some of these small cell sites or the signal, coax in its resiliency has always been able to repurpose itself to some degree. And, you know, MSOs and others are talking about repurposing the coax in that fiber deep architecture to power the fiber network. So again, getting the best out of coax, getting the longevity, continuing to leverage that infrastructure and that capital investment. There's many ways that coax has many years to go to live.
Cool. So one final question for the whole panel, and then one just for the Amphenol. So the first one to the whole panel, I'm just looking for a year or a time period. So looking into the future, if there is a day when coax is eventually replaced by full fibre to the home, how soon and what year would you predict that needing to happen?
What country do you have in mind?
In general, we'll keep it general. If you want to talk for the Netherlands, Rian, you by all means. But yeah, so what year would it be when coax is eventually replaced by a full fibre network, or has to be? Any predictions?
Years to come.
Years to come. I'd say you're looking more at a wireless way of doing this than going actually that way. I can't see a whole country being full fibre to every single outlet. I can't see it happening. I mean, I'd love to see it, but I don't see it being feasible. There's always going to be someone sitting there with their tin hat on saying, no, don't want it, not going to have it. How are we going to get to them? How are we going to actually do it? Just the amount of construction and civils going into that, it's immense. Yeah. I see it a long way off yet.
Oh.
Yeah, and I think, you know, we're still just about implementing DOCSIS 3.1. It's out there in the wild and it's being used, but it's not being used everywhere. And we're talking about DOCSIS 4 standard and how we can, you know, get up to 10 gigabits download speed and 6 gigabits upload speed concurrently. So, you know, it's more about how we're going to use that amount of data transfer. So probably, you know, coax and fiber and a fixed connection to the home is probably going to be around 10-20 years. And you'll probably have those more difficult sites popping up on a wireless network on the back of those connections rather than instead of.
Yeah.
Long after a young man.
That's a succinct way to put it. Right, so final question, and I'm conscious of time, and I will hand over to Tony just for a bit of a close. But for Tim and Nick, interesting one. Amphenol Broadband Solutions, what do you sell more of, fiber or coax products?
Coaxial product is the short answer to that one. You know, it's been the bread and butter of the company for, what are we up to, Tim? Is it 67 years?
48. Tom's Fiber was founded in 1948, so
Okay.
I agree coax is the majority, but fiber, you know, is accelerating. We still
Yeah,
sell a
absolutely.
lot of coax cable, though.
Awesome. So that's all from questions. We've pretty much managed to answer everything that's kind of popped up. Anything that hasn't been answered, we'll kind of take away and we'll get them kind of shared out. There'll be some mail following up from this within the next week or so. So we'll get some final answers for those. I am just going to say thank you on behalf of obviously the panel, both Amphenol and the SCTE. And I'm going to hand over to you, Tony, for a bit of a proper close, if that's all right.
Thank you very much, James. I've only got to say, to be honest, thank you all very much for joining us here today. I know where we are right now is a different sort of world we want to be in. It would be more fun in a lecture hall somewhere. This also works. And so the panel, thank you very much. Thanks for answering nearly every question. Really well done. I think we can all agree it's actually been quite fascinating to look at this. I mean, I've been in this business a long time. We all have. There's over 100 years of experience just sitting on the panel, which is frightening. When you start looking at this, I actually learned something as well today. That's even worse. I'm still learning. And it's only through discussions like these, we can take a step back and see actually how far we've come from putting a little telegraph, Morse code down the line to what we're actually doing now. And we're still trying to push it further and further. I'd like to take an educated guess to what's going to happen in the future. The only thing I can say is these relationships, and as I've seen today, there was 161 attendees that wanted to be part of this. I have received a few emails, couldn't get on, my work stopped this, sorry, make sure it's recorded. So I'm glad we were able to record all of this. To the attendees that are still here, all 51 of you, thank you very much for continuing this. This is not the last one we're going to do here. We hope to find some more Tims, some more Nicks, Reens, James, to continue this. To put this all together has taken us nearly 2 months from start to finish. So there's a lot of work that's gone on behind this. So I'd like to thank the SCTE back office. I'd also like to thank Kathy, Greg and Stefan from Amphenol. They made all this possible. They made this knowledge so we can give it to all of you here. I hope it was interesting. I hope it was informative. James, I'd like to say you have been a terrific moderator. You actually have. So that's your second sort of well done this year. I'll try and stop this. Thanks for also being there to moderate this. I can understand it's not easy. The audience, thanks for showing we're getting all this moving. As you leave today, please be conscious. I know you're all in a residential area, keep the noise level down, but there's also a survey to keep you busy. We've put 4 quick questions together just to try and find out how this went for everyone. If there's any problems, please tell us. If there was good things, please tell us. We're still learning. This is also new to us. We've only been sitting at home for nearly a year. This is still brand new for all of us. So thank you all very much. Please fill out the survey. Nothing more to say than there's another one of these coming. I actually know there's 2 on the way. So look forward to what's going to happen in February. Look forward to what's going to happen in April. And I'm going to try and get one in March as well. I'd like this to be a monthly thing we do. So if you've got any ideas what you'd like to put into here, if you'd like to know some more about what we've been doing, if you've got any question for us, send it in. My email is on there. keep it all done. Thank you all very much. Hope to see you out there soon.
Thank you all.
Are there any further questions coming in, just to make sure we can round it all off?
No further questions. A few thanks. So just thanks for everyone that is, and thank you for coming along.
Yeah, just on part of Amphenol Broadband Solutions, thank you very much to everybody at the SCTE who's put all this together. It's been a fantastic effort, and we're very privileged to be a part of this start of the series. It was sold to us as being guinea pigs, but you know, we'll take it. And yeah, thank you very much, James. You did a great job moderating, and thank you to Reen and Tony for your time today as well. And yeah, so just a big thank you from all of us here, and then thank you to everybody that's joined in and been a part of this experience. Thank you.